Hey guys, in this question we are going to look at a motion that is like a parabola, right? So when you hit a baseball, so it says that the baseball is hit from a height of 3 feet above ground, and it's going to at some point reach its maximum height. So you will hit it at an angle and then it's going to hit the ground. So right here is the maximum height point, and then right here is when it's going to hit the ground. So let's write down what we know. So we know that h0, which is the initial height, is 3 feet. We also know that the initial velocity is 114 feet per second. And then we have the angle with the horizontal. So that would be like this angle right here. That's your theta. That's going to be 36 degrees. Okay. Now, we also know that g, which is gravitational constant, is 32 feet per second squared. So by the way, if you are familiar with 9.8, that's when it's meters and seconds. But if it's feet, then it's 32. I will always provide the gravitational constant for you. So what we know generally is that the velocity looks like this, and these formulas are provided for you. So the x component is going to be v0 cosine theta, and then the y component of velocity is v0 sine theta, and then minus gt. And that's the jth component. So the first part is actually pretty easy to see because over here, like if you draw a vector of velocity, you will see that this vector is tangent to the curve at the maximum, and the y component of that vector is 0. So what you need to understand is that this part right here is going to be 0 when the ball reaches maximum height. So if you were to set it equals 0, so whatever is your 114 multiplied by sine of 36 degrees minus 32 equals t. So I'm sorry, not equals to, times t equals 0. And then if you solve this for t, you will get 114 sine 36 degrees and then divide that by 32. Okay, so that goes on a calculator. So let's put that in there. And then make sure that your calculator is set to degrees. Okay, now what I also recommend is saving that in some numbers. So this is, I'm going to call this T1 because I do not want to use a rounded version because I might get it wrong. So I'm storing it instead. Okay, so but let's just put that here. Now it says, I think 4 decimal places. So that's going to be something like that. Let's just check our answer. All right. And then if we want to find the maximum height is the y coordinate of the position, right? Now, what's the formula for the position? So the position is basically integration of velocity. So then you're going to have an extra t in there because it's like number t. And then over here, we'll get v0 sine theta t minus gt squared over 2. And then also from the initial condition, we have that plus h0 in there. That's the jth component, okay? So if we want to see the maximum height, we need to find this right here, okay? So like we need to actually compute that. And that's going to be the maximum height, okay? So let's do that. So we have v0, that's 114. Multiply that by sine of the angle, multiplied by that time that we found at T1 minus G times T1 squared. By the way, I'm just typing like literally T1, and then I'm dividing that by 2, and then plus H0. So H0 was 3 feet, right? G doesn't understand because I didn't define it. Okay, so that's just 32. Okay, so that would be my maximum height. It says 2 decimal places, so I guess it would be like something like that. Okay, now this part is where you have to solve a quadratic equation because you want to know at what time will the baseball hit the ground. So it'll hit the ground when this y component, or this right here, is going to be 0, right? Because when you hit the ground, your x is, from here to here, that's going to be your x, but your y is going to be 0. So you are trying to solve a quadratic equation. And so here's what I recommend you do when you want to solve the quadratic equation. Define A, which is the coefficient of t squared, which is negative 32 over 2, which is negative 16. Define B, which is V0 sine theta. So V0 is 114 multiplied by sine of 36 degrees. Okay, so that's your B. And then your C is going to be H0, which is 3. Now you're going to put the formula, use the quadratic formula to solve this. Okay, so the quadratic formula says that's going to be minus B plus square root of B squared minus 4AC divided by 2A. Now, this gives you a negative answer, which is not good. You do not want a negative answer because there are two of them, right? The plus and the minus. So you want the one with the minus. And that would give you the answer. So I'm just using the quadratic formula straight up typing it. So let's just save that here. And it says 4 decimal places. So that's going to be something like that, right? Okay, so I will also save this in, let's say, T2. So that's the time when it hits the ground. Okay, the next question says, what is the maximum horizontal distance? So the maximum horizontal distance is the x component, right? So we just have to compute V0 cosine theta and also include that t. Sorry, that t is also part of it. So we're going to have V0. Well, V0 was 114 multiplied by cosine 36 degrees multiplied by that time we just found. So that's going to be my answer over here. That's the maximum horizontal distance. So this says 2 decimal places. Now, this question, how do you figure this out? So it says the fence at the edge of the field is 11.5 feet tall and located 375 feet away from the home plate. So if you know that your horizontal distance is 375 feet, you know that V0 cosine theta t should be 375 feet. So you can solve this for t. You can take 375 divided by V0 cosine theta. That's going to give you what time that happens. So this is yet a third time. So this is going to be 375, divided by V0, which was 114. Sorry. And then times cosine of the angle. So that's 36 degrees. Okay. So that at that particular time, which we're going to call T3, and it happens before, obviously, it hits the ground. We want to know how far from the ground did that happen. So at some point over here, we want to know this vertical distance, right? So we need to plug it into the y coordinate of the distance. So let's go V0. So that's 114 multiplied by sine of theta multiplied by that time T3 minus 32 over 2 times T3 squared plus 3. Okay, so we know at that point the baseball was 10.9 feet higher. So it was 10.9, right? But the fence is 11.5 feet. So that's why the ball will not pass over the fence because the fence is taller. Okay, so that happens, then it's not going to pass. That's why this is no.